For the longest time, one of the absolute biggest challenges in artificial intelligence has been teaching a machine how to reason. We've gotten really, really good at teaching them to recognize things, a cat, a car, a coffee cup. But what about all the invisible connections between those things? Well, today we are diving into a totally groundbreaking paper from DeepMind that introduced a surprisingly simple idea that honestly completely changed the game.
Okay, so take a look at this image right here. For any modern AI, telling you what's in this picture is an absolute piece of cake. It would instantly spit out a list: purple cube, yellow cylinder, brown sphere, another smaller purple cylinder. But that's just a list of stuff. That's not real understanding, is it? True understanding goes way, way deeper.
And this is exactly where we find the AI's critical blind spot. See, if you ask it a question like the one on the left, what is the size of the brown sphere? No problem. Easy. It's just looking something up. But then you hit it with that second question. Are there any rubber things that have the same size as the yellow metallic cylinder? And you get a total system meltdown. So why? It's because the question isn't about one thing anymore. It's about comparing multiple objects across multiple properties all at the same time.
And that really is the central mystery we're unpacking today. What is the fundamental piece of the puzzle that these incredibly powerful, incredibly sophisticated AI models are missing? It's not about seeing more pixels. It's about seeing the connections.
So, to figure out what they were missing, we first have to understand why they get stuck in the first place. And for that, let's talk about what I like to call the puzzle piece problem.
Think of a standard vision AI, you probably heard of them, a convolutional neural network, or CNN, as a world-class expert on individual puzzle pieces. It is absolutely fantastic at analyzing pixels to tell you the color, the shape, the texture of any single piece you hand it. But here's the catch. It has absolutely no built-in idea of how that piece might connect to any other piece to form the big picture.
And in the real world, what this means is these models just fall flat on their faces. They can't easily compare things, like asking if the cube is made of the same material as the sphere. They get totally lost with spatial ideas like farthest away or to the left of, and forget about asking it to count things that share a property, like how many small shiny objects are there. Every single one of these tasks requires seeing the relationships between the puzzle pieces.
But then, the researchers at DeepMind had this amazing breakthrough. They realized, hey, instead of trying to make our puzzle piece expert even better at its one job, what if we just gave it a totally new tool, a whole new way to think about the puzzle as a whole?
And this is it. This is the hero of our story, the Relation Network, or RN. Now, the real beauty of this thing is its simplicity. It's not some massive, complicated redesign. It's just a small, plug-and-play module that you can add onto an existing AI. And its only job is to force that AI to stop looking at objects one by one and start comparing them, two at a time.
So how does this actually work? Well, the Relation Network acts like this relentless detective. After the main AI has identified all the suspects in the scene, all the objects, the RN takes over. It then systematically compares every single possible pair, the red sphere and the blue cube and the yellow cylinder, the red sphere and the yellow cylinder, on and on and on. For every single pairing, it asks one simple question. Based on the question I was asked, how are these two things related?
Okay, let's walk through the whole flow. Step 1, a vision model, that CNN we talked about, looks at the image and breaks it down into a set of objects. Step 2, a language model, in this case an LSTM, reads the question to understand what we're looking for. And then, step 3 is where the magic happens. The Relation Network takes every possible pair of objects and starts comparing them. Finally, it just pools all of that relational information it found together and uses.
It's a really elegant idea in theory. But, the proof is in the pudding. Does it actually work? Let's get to the results and see what happened when the researchers put this new module in the hot seat.
So first, they created this simplified test environment called Sort of Clear. And it was brilliant because it was designed to do one thing and one thing only: isolate and test relational reasoning. They asked two kinds of questions: the simple, non-relational ones, like what shape is the gray object, and the tricky, relational ones, like what shape is the object farthest from the gray object.
And the results? Whoa, they were incredible. On those tricky relational questions, the standard AI was basically just guessing. It only scored 63%. But the exact same model with this simple little relation network plugged in, it scored over 94%. It wasn't just a little bit better, it was playing a completely different sport.
But, okay, that was just the warm-up act. The real test, the main event, was going back to that original, incredibly complex dataset that we saw at the very beginning, the one called Cleaver, that stumped even the most powerful AI models of the time. The AI with the Relation Network achieved 95.5% accuracy. And get this, to put that number in perspective, human performance on the very same dataset is 92.6%. So for the first time ever, an AI wasn't just good at this kind of complex reasoning, it was actually superhuman.
I mean, just look at this chart to see how huge of a leap this was, especially on the absolute hardest questions. When asked to compare attributes, the previous best AI was completely stuck at around 52%. That's basically a coin flip. The RN-powered model didn't just beat it, it soared to 97.1%, even nudging past human-level performance. It's just, wow.
And this was no one-trick pony either. The researchers plugged the RNN into models for totally different problems. It crushed it on text-based question answering. It could even watch simulations of bouncing balls and correctly figure out that there were invisible springs connecting them just by watching how they moved. This thing is like a general-purpose reasoning engine.
Okay, so let's zoom out. A cool new AI module that gets amazing scores is one thing, but what does this actually mean for the future of artificial intelligence? Why does all of this matter so much? Well, the paper's authors really put it perfectly themselves. They said the ability to reason about the relations between entities and their properties is central to generally intelligent behavior. This isn't just a neat party trick for an AI. It is a core, fundamental component of what we even consider to be intelligence in the first place.
So let's just quickly recap the key takeaways here. First, relational reasoning has been this massive roadblock for AI for years. Second, we've learned that our standard, powerful AIs are amazing at processing data, but that is not the same thing as reasoning about it. The relation network gives AI a simple, dedicated tool for that exact job, and that allows it to finally discover all those hidden connections between things, all on its own. This kind of breakthrough really opens up a whole new universe of possibilities. It's a foundational step towards AI that is much more general and capable, and it leaves all of us with a really fascinating question. If AI can now truly start to understand how things relate to one another, what's the next great mystery it's going to solve?